Hello everyone, welcome to yet another video from me. I'm Damian, math tutor from Pusa Tuition 30D. So in this video, I'm going to go through the textbook questions from the Form 4 Chapter 7 Mathematics. So without wasting any more of your time, let's go to the questions. Alright, so let's look at the questions in the comprehensive practice. So if we look at question 1, the distance against time graph shows the motion of an express bus for a 14 minutes period. So we have a distance against time graph here. So in distance against time graph, they can ask you to look at duration of time, the distance, and also they can ask you to calculate the speed by looking at the change in distance over change in time. Okay, you always need to know speed is change in distance over the change in time. Okay, and also one more thing that they can ask for distance against time graph is your average speed, which is total distance over total time. So first question here, they ask for the duration when the bus is stationary. Stationary means when the bus is not moving. So when it's not moving, means the distance does not change. There is no change in distance, which is this part where the line is horizontal. Okay, this part where the line is horizontal. So that's where the bus is stationary. So they want the duration, means from 4 to 10 minutes. 10 minus 4, I get 6 minutes. Okay. And then for part B, the rate of change in distance in km per hour of the bus for the last 4 minutes. For the last 4 minutes means from minute number 10 to minute number 14. So it will be this part right here. So they want the rate of change in distance, which is basically the speed. Okay, rate of change of distance is basically the speed. So the rate of change of distance at that part, or the speed for that part, will be change in distance. So it goes from 6 km until 10 km. So the change in distance will be 4 km over change in time. So if I only take 4 minutes, okay, that would not be correct, because 4 km divided by 4 minutes will give you the unit in km per minute. But if you look at the question here, they specifically say km per hour. Okay, so in this chapter, you need to pay attention to the units that they want. Okay, they want in km per hour, so the unit of time you have to use hours. So 4 minutes to change to hours, I have to divide by 60. Okay, then it becomes hours. Then I will get 60 km per hour. Right? So if you want to key that into your calculator, if you are using ES or EX version calculator, then there's no issue. But if you're using MS version calculator, because the fraction is not in a fraction form like this, okay, it will just be like this. So you need to take 4 fraction bracket 4 divided by 60. Yeah, you need to bracket the 4 divided by 60. If not, it will just take 4 over 4. Then only they will divide by 60. But the 4 divided by 60 has to happen first. So you have to pay attention to that. That's for part B. And for part C, the average speed of the bus for the period of 14 minutes, you just take the total distance that is traveled. So it goes from 0 until the end here is 10. So means 10 km has traveled. Total distance is 10 km. So average speed 10 km divided by the total time taken, 14 minutes. But again, it wants the question wants km per hour. So we have to divide by 60 to change to hours. So once again, if Right, key into calculator, make sure you bracket 14 over 60 if you're using MS version. If you're using ES or EX version, you can always use the fraction form. Okay, so you will get 42.857, so I can round it off 42.86 km per hour. Right, that is for the first question here. Then, if we look at the second question, a car and a tour bus, so there are two things traveling, okay, over the distance. One is from 100 km away, go to 0. One is from 0 km, go to 150 km away. Okay. So first question here, they want the rate of change in distance of the car for the first 24 minutes. So you need to be aware which is which. Okay. So for the car, we have to only look at the car. So they want for the first 24 minutes. 24 minutes. If I take, you see 0.7 here. If I take 0.7 times 60, that is 42 minutes. Okay, that is 42 minutes. Which means the first 24 minutes is within this line here. Yeah, it's before it reaches 0.7 here. Okay, but the change in speed has no difference. Okay, the change in speed doesn't change. Sorry, the change in this rate of change in distance, which is the speed, doesn't change for this whole part of the journey. So it doesn't matter how much of this part we take. We can take this small, this much, or we can take all the way until here. It doesn't really matter because the speed is still the same. Okay, so we can just find the speed using the 0.7 and the 70 here. Okay, again, rate of change of distance is the speed. So I just take distance traveled, change in distance over the change in time, 0.7. I can just use 0.7 because the unit is correct. It's km and hours. Right? So 70 divided 0.7, I will get 100. So it's 100 km per hour. Then for part B, value of t. Okay, so to find value of t, we need something that tells us an information. Okay, we need an information that we can relate. Okay, so if I try to look at a car, okay, there's no information about how long is stationary and things like that. So I can't use the journey of the car to see. If I use the journey of the bus, okay, there is no information in the question here, but there is information in the diagram. I can actually compare this part of the journey, okay, with the journey of the whole journey of the bus. Okay, with the whole journey of the bus. Basically, the speed again doesn't change no matter how much of the journey we take. Okay, no matter how much of the journey we take. So if I take the whole thing here, okay, it will be 150 divided by 3 hours. It will be the same as the speed for just this part. Or I can also take from A until Q here. Okay, it's up to you which one you prefer. Okay, it's basically the same. Yeah. So let's say I take just this part. So the change in distance is 70, from 70 until 0, so 70 over the change in time from T until 3 hours, which means 3 minus T. It will be equals to 150 km divided by the time taken, 3 hours. Yeah. So this will be 50. Okay. I get rid of the 3 minus t, divide opposite times. So bring over times 3 minus t. Get rid of 50 times 50, opposite divide 50 equals 3 minus t. Okay. So 70 divided 50 is 1.4. I bring over the 3. Positive opposite minus, which is negative 1.6. Negative 1.6 is negative t. Cancel off negative t is 1.6. Yeah, that's the value of t here. And then for part C, the rate of change in distance in km per hour of the car for the last 80 km. For the last 80 km. For the car means the green color journey. So for the last 80 km will just be from Q to R. Because from 70 km to 150 km, that is the 80 km. So rate of change of distance again is just the speed. So we just take change in distance, 80 km, over change in time from 1.6 until 3. 3 minus 1.6, which is 1.4. So it's basically 80 divided by 1.4, which I'll get 57.142. So 57.14 km per hour. Yeah, that's for the question 2 here. Okay, so in this chapter there is another kind of graph, which is the speed against time graph. Okay, make sure you don't confuse between distance against time graph and speed against time graph. Okay, so speed against time graph. Okay, what they can ask you to find, they of course they can ask you to find the speed or the time that has passed, change in speed that has changed, change in time, or what is speed at certain point, things like that. They can also ask you to find the acceleration. Okay, because that is the change in speed over change in time. Yeah. Okay, change in speed over change in time. They also can ask for distance. Yeah. So we know speed is distance over time. I bring over the time, speed times time equals to distance. So speed times time. How do I get speed times time from the graph? It's basically the area under the graph. Okay, so distance, to find distance from your speed against time graph, we take area under the graph. Yeah, so definitely it will either be a trapezium shape, triangle shape, or a rectangle shape. Okay, it will definitely be among these 3 shapes. So make sure you know how to calculate the area for all 3 of these shapes. So if we look at the part A here, duration when the one more thing is average speed. Average speed is also calculated in a speed against time graph. So we will need the distance first, then only I can find average speed. So yeah, part A here, duration when the motorcycle travels at the uniform speed. Uniform speed again is when the speed doesn't change. Okay, so it's different from distance against time graph when the horizontal line, or distance against time graph is when it's not moving. But for speed against time graph, it's just uniform speed, constant speed. Okay, when there's no change in speed. So duration from 2 to 10. So 10 minus 2, which is 8. Follow the units given in the horizontal axis. So 8 seconds. And for part B, value of t if the distance traveled by the car and motorcycle are the same for the period of t seconds. So distance are the same means area under the graph for both the car and the motorcycle is the same. Okay. So for the motorcycle, it will be distance for motorcycle. Is the trapezium here, half times sum of parallel sides. This 2 to 8 is 10 plus 0 to 10 here, 10 times the height. Height here is 4. Okay, plus the other trapezium, half times sum of parallel sides. Parallel sides now is this 2, 4 and 10. Times the height, which is always 90 degrees to the parallel sides. So from 10 to t means t minus 10. Okay, so if I simplify this, half times 18 times 4 is 36, plus this one, half times 4 plus 10, 7, times inside 70 minus 70, yeah, which is 70 minus 34. Okay, distance traveled by the car is just a triangle, half times base, the t, times the height, 10. So it's 5t. So they say they will be the same, means 7t minus 34 equals to 5t. Okay, bring over the 5t, positive become minus, bring over 34, negative become positive. 2t is 34 times 2 opposite divide 2, which is 70. So the t value is 70. Yeah, that's for the question 3 here. Now we look at question 4. The speed against time graph shows the motion of particle for the period of 15 seconds. Calculate the rate of change of speed in meter per second square of particle for the last 6 seconds. Last 6 seconds means from 9 until 15 seconds, this last part here. Okay, rate of change of speed means basically the deceleration. But when they say rate of change of speed, basically I just use the gradient, because rate of change of speed when it's negative value means it's a deceleration, but when they say rate of change of speed, we don't just take the magnitude of it. We have to indicate whether it's positive or negative, whether it's increasing in speed or decreasing in speed. So rate of change of speed here will be going down, so it's negative value. Then take the change in speed, 7, divide by the change in time for the last 6 seconds. So basically I divide by 6. You can actually keep it in this form if you want. Okay, but of course if you go and calculate 7 divided by 6 and get 1.167, it is not wrong as well. Okay, negative 1.167 is also fine. Unit will be meter per second divided by seconds, then it's meter per second square. Yeah, That's why you can see the unit is correct. Meter per second divided by seconds. Then for part B, the value of V if the ratio of the distance traveled in the first 5 seconds to the last 6 seconds is 5 to 3. So ratio of the distance traveled in the first 5 seconds. First 5 seconds means this part. Okay. Last 6 seconds is this part. Okay. So they say the ratio is 5 to 3. So basically it's like this. You can, when it's given ratio, you can always put it in a fraction form. Means distance traveled in the first 5 over distance traveled in the last 6 seconds. I use 5 and 6 lah. Okay, equals to 5 over 3. Okay, which means 3 times of distance in the first 5 seconds is 5 times the distance in the last 6 seconds. Then I can form the equation and solve from there to find the value of V. So 3 times of distance in the first 5 seconds means the area of this trapezium. Half times sum of parallel sides. So sum of parallel sides will be 8 and V times 5. Okay. Equals to 5 times of half times the triangle. So half times base times height. 6, 9 to 15 is 6 times the height is 7. Yeah. So I calculate this. 3 times half times 5 is 15 over 2. So if I times 8 is 60. Plus 15 over 2 is basically 7.5. So it's, when I times the V is 7.5 V. This side I times 5 times half times 6 times 7, I get 105. So I get rid of 60, positive opposite minus, which is 45, times 7.5, opposite is divide 7.5. 45 divided 7.5, I get 6. So the value of V is 6. That's for the part B. As for the part C, they just want the average speed of the particle for the period of 15 seconds. Okay, average speed of the particle for the period of 15 seconds. So I don't have this distance yet. Okay, so let's find distance from 5 to 9 seconds. Half times sum of parallel sides. V is 6, so 6 plus 7 times 5 to 9 is 4. Okay, half times 13 times 4, 26. Okay. Yeah, this is in meters. Yeah, this 105 is the distance. Actually, it's 5 times, so it's different. I need the distance for all of it also actually. Distance for the first 5 seconds is half times 8 plus V is 6 times 5. Half times 8 plus 6 times 5, 35. Distance for the last 6 seconds from 9 to 15 seconds, half times 6 times 7, 21 meters. Okay. So average speed is the total distance divided by total time. Total distance, I just add all the distance together. So I just take the 26 plus 35 plus 21. 82 meters. Yeah. Average speed. If I just take distance over time, 82 meters divided by 15 seconds, I will get the speed, but it's not in the unit that we want because we want km per hour. So the meters I have to change to km divided by 1000, and the seconds I have to change to hours. So I can divide 60, or I can just divide 3600. Up to you, doesn't really matter. It's the same thing. So once again, when you key into a calculator, if you're using MS version calculator, make sure you put a bracket on top and below of the fraction. The numerator and the denominator, we have to bracket it if you're using MS version calculator. If you're using the fraction form, then it's okay. Okay, if not, you have to bracket 82 divided 1000, then over bracket 15 divided by 3600. Or you can divide 60 divided 60. It's the same thing. So you will get 19.68 km per hour. Okay, so as I've mentioned before, it's very important for you to pay attention to what is the unit that they want. Okay, so that's question 4. Then we look at question 5. Speed against time graph here shows the motion of 2 cars for a period of 45 minutes. Puan Nisha drives to town P from town P to town Q, and Puan Farah drives in the opposite direction. So first we want to find value of V if the rate of change of speed of Puan Farah's car for the first 30 minutes is the same as the acceleration of Puan Nisha's car for the period of 45 minutes. Okay, which means they're talking about the magnitude of it being the same. They're not really, because one is actually negative in a sense. Yeah, one is actually slowing down, one is speeding up. So, Puan Farah's car. Puan Nisha is from town P to Q. Puan Farah is opposite direction from town Q. So the green one is Puan Farah. The pink one here is Puan Nisha. Okay. So rate of change of speed of Puan Farah's car in the first 30 minutes means this part here. Okay, so I take the change in speed from 24 to V, so 24 minus V over change in time 30 minutes. It will be equal to acceleration of Puan Nisha's car for the period of 45 minutes for the whole thing. So change in speed 18 over change in time 45 minutes. Okay. Bring up the 30. 24 minus V is 18 over 45 times 30. Okay, divide 30 opposite times 30. 18 over 45 times 30 is 12. Get rid of the 24. Positive opposite minus. So negative V is negative 12. V will be 12. Yeah, that is the value of V. Okay. Then, now for part B, the distance from town Q in km when the two vehicles meet. This question actually is wrong. Okay, this question is actually wrong. They actually made a mistake here, because this is a speed against time graph. When the two graphs meet, it doesn't mean that the distance, they are at the same distance point. Okay, you can only do that for a distance against time graph. So I've actually checked the answer as well, and the answer that I give, the question that they should be asking is, when the two vehicles, instead of meet, it should be drive at the same speed. Okay, when the two vehicles drive at the same speed, which is this point right here. So from town Q, the one that is traveling from town Q will be Puan Farah. So we look at the distance that has been traveled by Puan Farah, which is this part, this trapezium here. So the distance will be half times sum of parallel sides, 24 plus V, which is 12. Yeah. Okay, but this is in correct. This is in meter per second, then times the time. The time here is in minutes. Okay, so in order for us to find a distance, I need to use the same unit of time. So 30 minutes I have to change to seconds, means I times another 60. But this distance that I will get, if you calculate this, half times 24 plus 12 times 30 times 60, you will get 32,400, which is the distance in meters, but they want in km, means I will divide by 1,000, 32.4 km. Yeah, which is the answer given in textbook. Yeah, so the question is actually wrong. Okay, textbook can be wrong as well if you're not aware of it. Yeah, and this is the case of it. And then part C, the time in minutes taken by Puan Nisha to reach town Q if the acceleration of her car does not change. Okay, so if the acceleration of the car does not change, time taken by Puan Nisha to reach town Q. Basically, we are assuming that once I finish here, it will reach town P. Yeah, which isn't exactly right as well, but I guess the writer of the textbook somehow wants to mean it that way, which is really not a right way to set the question, but let's go with it. So I already have the distance for this part. We find the distance for this triangle as well. So we take half times base, 15 minutes, but I have to change to seconds, times the height, V, 12. Okay. So it's half times 15 times 60 times 12. Half times 15 times 60 times 12, which I get 5,400. This is in meters. Yeah, you can use meters, you can use km. It's not really so important. Let's use meters, so I don't need to convert the unit for the other one. Okay. So basically we need to express in terms of the time. So we need to express distance travel in terms of time. So if I extend it any further, I don't know the time, I don't know the distance traveled. Okay, but I know that the distance, sorry, I don't know the speed also actually. So we don't know what speed it reaches, but we know that the acceleration doesn't change. So change in speed over change in time is equals to the change in speed over change in time at another point. So I can take 18 over 45. I can also take the v over 30. Yeah, 12 over 30. It will give us the same thing. If I take 12 over 30 is 0.4. 18 over 45 is also 0.4. Okay, so bring up the t, s is 0.4. The speed is 0.4 times of the time. Okay. So the distance traveled, it will be still a triangle because it's still the same acceleration. So change in speed 0.4t over the change in time, I put it as t, equals to the total distance traveled, 32. Oh, sorry, my mistake. That's the acceleration. This area, half times base, t, I have to times 60 because I have to change it to seconds, times height, the speed, 0.4t, equals to total distance, 32,400 plus 5,400. Okay. Cut here 30 times 30, opposite divide 30. So this is 0.4t square. So let's calculate this. 32,400 plus 5,400, 37,800 times 30, opposite divide 30, 1260. Okay, times 0.4, opposite divide 0.4, 3150, then square opposite square root. Hold on. So yeah, it's actually square root of 3,150, which is 56.12. Okay, that is the true answer to it. But the answer given in textbook is different. Okay, if I try to look at the answer in the textbook, it is 60. Okay, it is 60. But in order for it to travel the same distance with a time of 60, then the speed will actually reach 21. Okay, and if I take 21 divided by 60, I will actually get 0.35, which has a different acceleration. Okay, which has a different acceleration. So that doesn't really make sense. Okay, so the question actually is wrong. Yeah, I can confidently say the question the question has a problem to it. Okay, because like I said, this is a speed against time graph. It should not represent the distance traveled, but I'm assuming that it reaches here, it should be it should have reached town P, considering that it has stopped. So considering it has already stopped, it should have reached town P. So that kind of makes a bit of sense, but this is a very badly set question. So question 5 is really not a good question that has been set. Okay, so let's move on to the next question. Okay, if we look at the question 6. Alright, so for question 6, distance against time graph, I have motion of 2 cars, distance 100 km. OA is for motion of Mr. Lee, and OB is for motion of Mr. Encik Dollar. So Mr. Lee moves at average speed of V km per hour, while Encik Dollar is V minus 2 km per hour. Okay, so they want the value of V. Given difference between time taken by Mr. Lee and Encik Dollar to reach the destination is 25 minutes. So we have to compare the average speed. Okay, so one is V minus 20. So you can compare the time, you can compare the speed as well actually. Okay, so it's actually easier to find it's probably easier to find the time first. Okay, but either way, basically we look at average speed. Average speed for Mr. Lee is V, and average speed is total distance traveled over total time taken. Time taken is T minus 25 minutes, but this is in minutes, but it should be in hours. So I have to divide 60 to change to hours. Okay, so means it is 6,000 over T minus 25. Yeah. For Encik Dollar, V minus 20 is 100 divided by the time. Again, I have to divide 60 for the time to change to hours. So it's 6,000 over the time. Yeah. So I can just use simultaneous equation. I substitute equation 1 into equation 2. 6,000 over T minus 25 minus 20 equals 6,000 over T. Okay. So each of the term I times T and T minus 25. I get rid of the denominators. Then I have 6,000 T, okay, times T minus 25, this will be gone, times T here, 6,000 T. 20, I times T and T minus 25, And 6,000 over t times t, this is gone, times t minus 25. Yeah. So it's 6,000 t minus 20t square, same sign, plus 20 times 25 is 500. So 500 t equals 6,000 t minus 6,000 times 25. 150,000. Yeah. So if I minus 6,000 t on both sides, this 2 becomes 0. Okay, then it's easier to count. So negative 20t squared plus 500t, bring over the 150,000 plus 150,000 goes 0. Get rid of the negative 20, divide everything by negative 20. T squared minus 500 divided negative 20 is negative 25. Then here also minus 150,000 divided by negative 20, 7,500. Go 0. Factorize. So you can use calculator or you can just you can also do the manual method, list down factors. But for large numbers, generally it's better to just what do you call it? Use calculator. Okay. It's basically 75 times 100. So minus 100 plus 75, so that I get minus 25. So if t plus 75 is 0, t is negative 75, which is not possible. Time will never be negative, means time must be 100. Okay. T must be 100. So V is, I sub back into equation 1, substitute back t equals 100 into equation 1, then I get V. 6,000 divided by 100 minus 25. So it's 6,000 divided 75, which is 80. That's for part A. And part B, I already have the t, so the time in 24-hour system, Mr. Lee reaches his destination. It starts at 8 o'clock. So t is 100. 100 means 1 hour and 40 minutes. 60 minutes plus 40 minutes, 1 hour and 40 minutes. So I plus 1 hour and 40 minutes. So is, oh sorry, my mistake. Plus 75 minutes. 1 hour and 15 minutes. Okay, 1 hour and 40 minutes is for $100. So 0915 hours. That's the time where Mr. Lee reaches. Okay, that's question 6. So yeah, this kind of question we need to use simultaneous equation to solve. Okay. Question 7. Diagram 1 shows the distance against time graph of car A for a period of t seconds. It's given average speed of car A is 25 meters per second. Calculate value of t. So average speed of car is 25 meters per second. I want to find t. So total distance traveled which means 1 km and another km, because it goes away, comes back. So 2 km, but I want meter per second, so means 2000 meters divided by the total time taken in seconds is equals to 25. So bring up the t, bring down 25. So 2000 divided 25 is the time. Time will be 80. Yeah, that's A1. A2. Describe motion of car A for a period of t seconds. So generally we want to look at the speed. Okay. If we describe according to the average speed here, I can say the car moves with, I use the information that we're given, average speed of 25 meter per second for distance of 2 km. Yeah, from the graph, 2 km, and what we just found, 80 seconds for 80 seconds. Yeah, just describe according to the information that we have. Then part B. Diagram 2 shows the speed against time graph for car B. It's given that uniform speed V of car B is the same as the average speed of car A, and both vehicles travel the same distance. Okay. So if the values of t in seconds for both graphs are the same, calculate the duration in minutes during which car B moves at uniform speed. So yeah, if you just read the question, I know a lot of people might get confused. Okay, it's a bit long. So let's break it down. Okay. Uniform speed of car B. Okay. Uniform speed of car B means this part right here. Okay. It's the same as average speed of car A. Okay, it's the same as average speed of car A, which means this is 25. Okay, this is 25 meters per second. Both vehicles travel the same distance. Both vehicles travel the same distance. Means distance is 2 km. If the values of t in second for both graphs are the same, t here is 80. Okay, so I want a duration during which car B moves at uniform speed. Yeah. So I know here is 100. I don't know how long is the time from here to here. Let's just call it X. But they say distance is the same. is also 2 km. So using the distance, how we find distance from speed against time graph, we can find the value of x here. So area under the graph, half times sum of parallel sides, x plus 100 times height 25 equals to the distance. This is in meters because meter per second times second, so 2000 meters. Yeah. Okay. Let's get rid of 25 and 1/2. 2000 times 25, opposite divide 25. Sorry, divide 25. Fraction, bring over, flip it around. Okay, or divide 2, opposite times 2. So 2000 divided 25 times 2 is 160. Plus 100, opposite minus 100, which is 60. Yeah. So this 60 is seconds. Means the duration is 1 minute. Because from the question, they say they want in minutes. Yeah. So that is how we solve this kind of question. Yeah. So slowly look at parts of the information one by one. Then we compare back, we can fill it in. Yeah. Then we see what we are finding at the end, which is duration here, the length here. So we need to use the area under the graph. So basically that is for the chapter 7. So graphs of motion chapter is basically just these two type of graph. Okay, distance against time graph, speed against time graph. Gradient for distance against time graph is the speed rate of change of distance with respect of time. Basically the speed. Okay. Then speed against time graph, gradient is change of speed over change of time, which is rate of change of speed. So it's generally acceleration. Yeah. So both we can find average speed. For speed against time graph, we can find distance, which is using area under the graph. Yeah. So that's the main parts of the chapter 7. So yeah, I'm Damian from Futsal Tuition 30. So if you have liked what I have gone through in this video, do follow us on our YouTube channel, our Insta, our Facebook. You can also follow me. You can also follow me at my Instagram. At Damian Math. Yeah. So thank you for watching. Feel free to subscribe to us and follow more of our videos next time. Bye bye.